Welcome back to Practical PyTorch. In this video you'll see how three settings, stride, padding, and channels, decide the size of a convolution's output. Get one wrong and the shapes do not match, the most common mistake with convolutional networks. A filter slides over this 5x5 grid. The bright frame is the filter. It writes a smaller 3x3 grid. Three settings decide that output shape, stride, padding, and channels. Getting them wrong is the error people hit most. This video has three parts. First, stride, how far the window jumps each step. Second, padding, and a simple formula for the output size. Third, channels, many filters that make many feature maps. Each setting changes the output shape in its own way, and one formula ties stride and padding together. First, stride the step size. This is how far the window moves each time it slides. Stride is how far the window jumps. Stride 1 moves one cell at a time. It stops at every position and writes one output value each time. Across 5 cells, the window starts at column 0, then 1, then 2, 3 stops. 3 stops across, and 3 down give a 3x3 output. Stride 2 jumps 2 cells at a time. So from the first stop, the window leaps to its next stop here. That is the jump 2 cells, not 1. The position in between is skipped. The window starts only at column 0 and column 2, 2 stops. Fewer stops make a smaller output, 2x2, not 3x3. The stride argument does exactly this. The first call uses stride 1, and the shape ends in 3, 3, a 3x3 output. The second call uses stride 2, and the shape ends in 2, 2, a 2x2 output. The same grids we just counted. Next, padding and the formula for the output size. Padding protects the size when the window reaches the edges. Without padding, look at the top left corner cell. The window can never sit centered on it. The same is true at the bottom right corner. The window cannot reach past the border. So there is no output centered on the edge cells. 5 in gives 3 out, the map shrinks. Padding adds a border of zeros around the input. This dashed ring is all zeros. Now the window can center on the edge cells too, because the border gives it room. Those zeros are only used while the window slides. They are not part of the output. With the border, 5x5 in gives 5x5 out. The size holds. PyTorch has 2 names for this. Valid means no padding, so the map shrinks. Same means pad just enough to keep the size. 2 names for 2 choices. One formula settles the size. Floor of h minus k over s plus 1. H is the input size. K is the kernel size, how wide the window is. S is the stride, the step size. The plus 1 counts the first window position. The floor drops a last window that only partly fits, and the same formula runs on the height and the width. Padding adds p cells on each side, p on the left and p on the right, so 2p in total. That 2p joins the top of the formula, floor of h plus 2p minus k over s plus 1. The rest of the formula stays the same. Let's plug in numbers. H is 5, k is 3, s is 1, and p is 1. 5 plus 2 minus 3 is 4. 4 over 1 is 4. 4 plus 1 is 5. Same size in, same size out, exactly what same promised. Now a 32 by 32 input with a 3x3 kernel. The first call has no padding, and the shape ends in 30, 30. The border shrank it to 30. The second call uses stride 2, and the shape ends in 15, 15. The third call adds padding 1 at stride 1, and the shape ends in 32, 32. The size held. Each number is the formula run for you. This is the common mistake. Asking for padding same together with stride 2 makes PyTorch stop with an error. The rule is simple. Padding same is only allowed at stride 1. That is a PyTorch rule. For a bigger stride, set an explicit padding number and let the formula tell you the size. Last channels. One filter makes one feature map, and many filters make many feature maps. Let's see how the depth going in and the depth coming out are set. A color image is 3 planes stacked together, red, green, and blue. This is the first plane, channel 0. The second plane, channel 1. And the third, channel 2. That depth is the number of input channels. Here it is 3. In PyTorch you read the shape channels. First CHW, channels height, width, and with a batch in front it is N, CHW. Output channels is how many filters you run. This is the first filter. The second filter. The third. And the fourth. Each filter has one 3x3 slice for each input channel, and those slices are added into a single value. So 4 filters give 4 maps, not 12. 12 would be 4 times 3, but the 3 channels get summed away. Each filter writes one output plane. This is the first. The second. The third. And the fourth. 4 filters, 4 output planes. The output shape is 4 by 32 by 32, depth 4. One output plane is called a feature map. It is the response of one filter across the whole image. In PyTorch this is one line. Com2D34. 3 sets 3 input channels, 4 output channels, and a 3x3 kernel. The weight shape is 4, 3, 3, 3. Read it as out in kernel height, kernel width, 4 filters, each 3 channels deep, 3 by 3. That is 4 times 3 times 3 times 3, which is 108 numbers. And the output shape is 1, 4, 32, 32. The 3-channel image became 4 feature maps. It stayed 32 by 32 because padding is 1. Without it, a 3x3 kernel would shrink it to 30. Let's watch filters at work on a picture. This is a made-up grayscale picture, not a real photo. A bright shape on a dark background crossed by a diagonal. It uses just one input channel this time, which keeps each map simple to read. Run 4 different filters, and each one pulls out something different. The first finds vertical edges. The second finds horizontal edges. The third blurs the picture. The fourth is a Laplacian, and it outlines every edge at once. Stack 2 of these layers, and a later cell depends on a wider patch of the input. That patch is called its receptive field. Let's review. Stride sets the step. A bigger stride makes a smaller output. Padding adds a border of zeros to protect the size. The formula, floor of h plus 2p minus k over s plus 1 settles the shape. An output channel sets how many feature maps you get. Next, pooling. Your turn. The input height is 32, the kernel is 3, the stride is 2, and the padding is 1. What is the output height? Pause and work it out. Okay, here it is. It is 16. 32 plus 2 minus 3 is 31. 31 over 2 floored is 15. Plus 1 is 16. Notice that padding 1 did not keep the size at stride 2. Same only means same size at stride 1. That is the output shape settled. Next, we'll look at pooling. Pooling shrinks the map on purpose and keeps the strongest signal. See you there.